first off, thank you so much for
Absolutely.
talking to me. I mean,
of course.
we're underneath your beautiful beast.
Yeah, it's crazy. Can you believe this is even here?
I was here a month ago, literally standing right here, and you had a tube and a pointy tube, and now you've got this. I mean, how do you do that? Is it just sheer will?
I don't know. I think I've learned a lot of lessons about how to make things go fast, and then I've propagated those lessons to the SpaceX team, and there's just like an incredibly talented, hardworking team at SpaceX. Yeah. And just taking the general approach of if a design is taking too long, the design is wrong, and therefore the design must be modified to accelerate progress. One of the most fundamental errors made in advanced development is to stick to a design even when it is very complicated, and to not strive to delete parts and processes. Another thing that, like, you say, like, what are the mistakes that smart engineers make? I think that one of the biggest traps for smart engineers is optimizing a thing that shouldn't exist. When you have a rocket engine, what are you trying to do? You're trying to shoot things out as fast as possible in a straight line.
Yes.
Say, like, what's the theoretical value of, say, a LOX kerosene engine as compared to a methane engine? The kerosene actually looks more compelling than it really is, because you can't achieve the high combustion efficiency with kerosene that you can with methane. So you actually want to say, what is the actual achievable combustion efficiency times the theoretical chemical energy? That's the real number. Right. And this is where methane starts to look really good.
Yeah.
It's like very hard to get to like 96% combustion efficiency or even 95% combustion efficiency with kerosene. But with methane, you can get 98 easy, 99 with a little bit of difficulty.
And so you don't think, you're just telling me now, spoiler alert, you're probably never going to see a full flow stage combustion cycle aerospike engine produced by SpaceX.
If somebody can show that we're wrong, that would be great.
Yeah.
Like, if somebody can explain, like, wow, there is a way to make your design better, this is a gift.
Right.
I would be like, thank you for this great gift. Wow, this is awesome. It's definitely, like, the worst thing would be, like, we want to do some dumb design and stick with our dumb design.
Right.
That would be insane.
Right.
So I would love it if somebody could show how an aerospike is the smart move. In which case, we'll just do an aerospike.
Yeah, just do an aerospike.
Yeah,
There's a reason they haven't been used.
Maybe aerospike is right, even though it's not been done before. But you just have to show that your combustion efficiency is not affected, and that you're straightening the flow sufficiently.
Yep. To get your expansion ratio.
Yeah. Also, if you've got a two-stage rocket, like, I think, like, this is the other thing. Like, you've got a two-stage rocket where your boost stage is primarily in atmosphere and your upper stage is primarily in vacuum. Yep. Then you can specialize for a vacuum nozzle and a sea level nozzle. Right. And then you're like, why do you need the aerospike? Right. It's only if you want to try to do single stage reusable, then that's when you start, like, having to reach for the aerospike. Right. Yep. Yeah. That's awesome. Yeah. Aerospikes with Elon Musk. Hey, thank you so much. Well, I would love it if somebody could show, like, hey, you're missing the mark, you could do this different thing, and this would be a better move. That would be, thank you, please. Right. Yeah. Yeah, of course. Absolutely. Yeah, totally. Hey, thanks for your time again. Seriously. Yeah, pleasure meeting you. Even when I'm exposed to this all day, it's still like, holy shit, it's still mad. Yeah. To see it actually there. And I was up in the nose. I'm going to post this later, but... Jack Bayer's photo. Bayer, he got a photo of you, like, I think, like, peeking out of it. Well, like, this is when I was inside there. Oh, shit. No way. Oh, and those are the header tanks? Yeah. And all the batteries, you got what, 6? We've got 4 Tesla 100 kilowatt hour batteries. Yes. That were just, like, basically welded onto the header tanks. Right. Yeah. Oh, we didn't even talk about that. You're doing Model 3 motors, basically? Yeah. Oh my God. That's I mean, I don't love I think we should just have electromechanically. I think we're all going to, probably with Mach 3, move to a purely electromechanical actuators for the flaps. Right. Currently, it's electric motors. It's like Tesla motors and batteries that essentially pump hydraulic fluid into an accumulator, and then the hydraulic piston moves the flap. Yep. But it'd be simpler to just have the motors directly just kind of like worm drive the flap. Yeah. So that's awesome. Yeah. And also the way the header tanks are done right now is crazy. We shouldn't be carrying the header tanks like cargo. I think we want the header tanks to be integral to the tip. So essentially, like, just take the tip, use the tip of the rocket as the as half
top.
of the header tank, and essentially mirror the main tanks, but in small form in the nose. So just have two domes. And have the oxygen and fuel in the tip of the rocket, not carrying the tanks like cargo, but having the tanks
just integrated, right?
Yeah.
Like, okay.
Just a mini version of big tanks.
Right. Okay. And then because you don't have an extra wall and everything too.
You have extra wall, no mounting planes.
Yeah. Gotcha.
Like in the early days of rocketry, like V2 or whatever, like the fuel and oxidizer tanks were carried like cargo in the aeroshell.
Oh, really?
Yeah. In the early days of aircraft and rockets, the propellant tanks were carried like cargo.
Right.
And now modern rockets, rockets and airplanes, like the wing is just a fuel tank in wing shape.
Yeah.
Yeah, we just do the same for the header tanks.
I love it. Yeah. Thanks again.
All right. Thank you.
Yep. Thank you, guys. Sorry, I didn't mean to keep him so long, I guess.